Leetcode 647, palindromic substrings. A medium problem, and it's quite standard for medium, so nothing especially hard or especially easy, just your standard medium problem. And here is the description. Given a string s, that's our input, a string called s, return the number of palindromic substrings in it. And so we have to find first all the substrings, meaning individual subparts of our string. And then for each of them, we have to check whether it's a palindrome or not. And if it's a palindrome, then we have to somehow keep track of all the palindromes that we have found so far. And by the end, we have to return as an output the number of palindromic substrings. Yeah? So we have to keep track of how many we found so far and then return that number as our output. And here is a hint or additional explanation. A string is a palindrome when it reads the same backward as forward. So of course it's standard, or not standard, but very common thing in those interview questions or algorithmic problems, and that they have to do something with palindromes. So I assume you have already heard something about them, but here is an example: level, or another example, radar. Yeah, and no matter whether you read it from left to right or right to left, it reads the same. Yeah, so here is L and here is L, E, E, and V in the middle, and similar for radar. So those are famous examples of palindromes. And additional explanation is for substring is a continuous sequence of characters within the string. So each subpart, but important thing is that order matters. And so we cannot just toss characters around in whatever way we want. We have to keep the same order in which they arrived in. Yeah, so we take them from input string, and we cannot just change them in any manner. Sorry. And here is an example. Example 1, ABC, and the string itself is not a palindrome, but it has 3 substrings which are palindromes. And what are those? Each individual character counts as a palindrome. That's the first thing that's worth noticing, that even a single character is also a palindrome. And the second example is a little bit more interesting. We have 6 palindromes inside it, palindromic substrings. And what are those? So it's AAA, 3 A's together. And each A, of course, is a palindrome since each character. And important thing here is to notice that the duplicates don't matter. And so we can have character repeated as many times as possible. It still counts as a separate character. And those substrings, so we don't have to, for example, have an odd number of characters. Palindromes can also be even. Yeah, so AA like this and AA like this. Those are both substrings which are palindromes. And the last important thing is that the string itself also counts as its own substring and can also be counted for the output if it's a palindrome. Yeah? And in that case, the string itself is a palindrome, so we have 6 substrings which are palindromes. So let's maybe copy that and think about some algorithms that we can create in order to solve that problem. So for sure we will need a counter and to keep track of all the substrings. We also need some way to get those substrings. So we probably will have to iterate in some manner through substring. And my idea is to get always single character and try to expand it into a bigger substring, as big as possible, until it's no longer a palindrome. Yeah, so we can always take one character to the left, one character to the right, check if we still have palindrome. If so, we keep expanding until it's no longer a palindrome. And that's more or less it. We just iterate through it, check all possible substring building up from the substring in the character in the middle, and increase the counter whenever we find a new palindrome. So try expanding to the left and to the right until substring is no iterate to string here. Yeah, or through the input event is no longer a palindrome. And that's the whole algorithm expressed in words, and we'll try to convert it into code in a couple minutes. But first, let's try to find all the substrings here using that strategy and increase counter whenever we find a palindromic substring. So let's maybe also write down all the substrings that we found so far. And we start with A, and the first character. And maybe we can do it like this. First one will be A. And is individual character a palindrome? Yes, it is. So we increase the counter. Now we can try expanding it to the left and to the right. But of course, we don't have anything on the left. So the next substring is AA. And it's also a palindrome. Yeah, and then because we already reached the end here, we just move to the next one. We can no longer expand it to the left. And that one is the next A, which again is another palindrome. And we can expand it to the left and to the right, like this. That would be our next substring. And again, it's a palindrome, so we have 4. And because we cannot expand anymore, we reach the boundaries. We try with this one. And again, it's a palindrome. So I think that you get it by now, or I hope so. What did I mean by that strategy? Because it's quite simple. And right now we found the last one. There are no substrings that we can consider. And we have found all 6 of palindromic substrings. And so let's try and write down those thoughts in more concrete way using Python. Well, for sure we need a counter. By the end we'll return that counter. And we also need some kind of loop for iteration. Yeah? Let's just write down the skeleton and then we will fill in the blanks. And we also need a way for expanding, and we can use helper function for that. We will provide left and right. Yeah? And we'll try expanding the substring and increasing the counter. And here's the most important part. Whether we will be creating 3 variables or just 2, and how to work with them to create the least amount of work for us possible. And my idea is to create center or middle in range, not 4 again, in range 2 times n minus 1, where n is equal to the length of our string, so number of characters inside it. And from that, we just need to create left and right, which will start either in the same place, center divided by 2, yeah, and right will be equal to left plus modulo division by 2, so the remainder of the division by 2, and yeah, just like this. So that operation here in this parenthesis will be either 0 or 1. And so either left or right start at the same place, or right is shifted by 1 to right. And then we can expand left, right. And here, while left, what's the boundary for left? 0. Yeah, it cannot be less than 0. It's greater or equal to 0. And what's the boundary for right? It's has to be less than n. And what's another condition? We want them to check for palindromes. Yes, so s on index left has to be equal to s on index right. And while that's the case, we increase the counter by 1, and we can also shift left by 1 to the left and shift right by 1 to the right. Let's see if that works. And of course, I just misspelled, as always, something. Expand. Local variable counter, so let's make it bound to the class, to the objects. Self counter, and here return self counter. It works for first two cases. Now let's try them on all the cases, and we beat 82% of our competitors. Let's try running it again. And now we are just in the middle. So let's try one more time. And again, 82%. So probably most of the people use something similar to what we did here. And maybe there are some little bit more advanced algorithms that give an edge for runtime. But that's not the topic of this video.